Welcome to our new XLive webinars. My name's David Cunningham. I'll be your host for the day. I'm one of XBlue's commercial directors. So as you're all well aware, various cancellations and postponements of industry trade shows has allowed us to, has locked us down in various locations, and we're unable to meet you at those events. So we're going to come directly to your location through a series of live interactive webinars over the course of the coming weeks. This is our first webinar. It will cover the new GAPS M5 product. The agenda will roughly be around about a 10-minute presentation with the product manager, who I'll introduce shortly, followed by a sort of interactive question and answer session. So please feel free to post any questions on the platform on the right-hand side of the screen as the presentation progresses. We'll try and answer as many as we can during this session. Any questions we can't answer, we can address after the event, either via email or perhaps we'll produce an FAQ summary of all the questions. So what I'll do now, I'm based here in Paris, in France. And due to the travel restrictions, we're not able to get together with colleagues elsewhere. So I'm introducing you here to Paul Uvoras, who's based down in Brittany, in Brest, in Brittany, at our acoustics factory. And Paul is our product manager for our USBL product ranges. So welcome, Paul.
Hello, David. Hello, everybody.
And so as we've mentioned, we're here to present this new USBL product, the GAPS M5. And maybe, Paul, you can briefly explain what is GAPS M5.
Yes, sure, David. The GAPS M5 is our new USBL product we've decided to make in order to extend our USBL range, because for more than 15 years now, we had the GAPS, the only solution we provided, and now we decided to extend the range. So the main idea of this new product is to bring the benefits of our GAPS to new users, to benefit from the unique characteristic of the GAPS USBL and extend the range of applications. So this new product have, I would say, four main benefits. And like the original GAPS, it does not require any calibration on the field thanks to its embedded sensor, and it is also designed to vertical and horizontal tracking, which is a very good condition for this new product. And we are now export-free, GAPS M5 export of restriction exportation, and then it is really easy for the user to ship it from a country to another.
Okay, so in summary then, so the architecture is the same as the original GAPS product. We're incorporating an integral high-grade motion sensor. It's free of any export control, and because of the way it's produced, it requires no calibration. So can you tell us a little bit more, Paul, about what's inside?
Yes, in this new GAPS, we kept the architecture of the original GAPS. So inside this GAPS, in the bottom part, in the top part, I mean, we have an attitude and true heading sensor, which is an Octans Nano. This is based on XBlue fog technology. And this is a very good source of motion and true heading. This kind of sensor is also used in subsea military and also in space industry. So it makes a very reliable sensor. And on the bottom of the GAPS M5, we have a 3D acoustic antenna, which is made using one acoustic transducer for the emission of the interrogation signal. And we have, again, 4 hydrophone, omnidirectional hydrophone that allow tracking in every directions.
Okay, so the summary then is we got the Octans Nano in the upper part of the device, and then the acoustic array beneath with the 4 legs, the same architecture as the original GAPS. What about the performances, Paul, of this new member of the product range?
The main performances of this new GAPS, first, the accuracy. So we are better than 0.5% of the distance. It means at 500 meters of distance between the gaps and the subsea vehicle you are tracking, you would get an accuracy within 2.5 meters. Then the range, the maximum operating range is 1 kilometers, 995 meters to be precise, making it calibration free of export. And it is also calibration free. This is a very important new benefit in this GAPS M5, because with these gaps, the user will have never to calibrate it. It is calibration free by design. And it is also designed for vertical, horizontal tracking, and it is possible to use acoustic communication to send and get binary data to an AUV, for example. So in fact, we kept the benefit of the gaps and adapt the performance in order to propose a cost-effective product that just fits the customer and the user requirements.
Okay, so then the key performances then are, it's a roughly 1,000-meter range or a limit of 1,000-meter range. 0.5% of range is the accuracy. It never needs calibration, and it's free of export control, and it's delivering the full omnidirectional tracking capability of the original GAPS. Mm-hmm. Okay, so just a quick one about the name, Paul. Why GAPS M5?
Yes, that's a good question. In fact, in XBlue product range in general, we use 3, 5, and 7 to qualify the level of performance of the system. As GAPS M5 is an accurate, high accuracy USBL system, we decided to use the 5. And then the letter, the M, we chose the M for medium frequency, because we use medium frequency acoustic signal for the acoustic positioning.
Okay, so it's medium frequency and it's the sort of mid-range performance, and the original GAPS has been redesignated GAPS M7.
Yes, GAPS M7. Okay. As the original GAPS is a top accuracy, we decided to use GAPS M5, M7, and then we have a coherent range of USBL product.
Got it. Okay, thanks for that. So moving on now from the product itself, what's inside, the performances. What about applications, Paul? Where do we see the sweet spot for GAPS M5?
Yes, this GAPS M5 is designed for various applications. In fact, the DNA of GAPS systems in general, it is multitasking. So these GAPS will be perfectly suitable for marine work, such as structure deployment, anchor positioning. It will be really suitable also for ROV tracking, diver tracking, and I would say in general, any vehicle tracking, including AUV fleet, thanks to its omnidirectional capabilities. It will be really also suitable for dynamic positioning, more especially in shallow water, for example, for wind farm construction. When DP are required in shallow water, these GAPS will be a very effective acoustic transducer. Okay,
so multitasking, that's the key message. Omnidirectional tracking, shallow water applications. We talked a little bit about deployment methods previously, Paul. Any comments about that? Yes, this GAPS is ready to use, ready to operate. It's really easy. It is even maybe a bit easier than the original GAPS, because it is a bit shorter, a bit lighter. So it can be controlled locally, it can be controlled remotely, it can be deployed on any size of vessel, from the 5-meter length semi-rigid to the jack-up vessel. In fact, there is no limit in the GAPS integration. This is really plug-and-play product. Okay, yeah, so just as the original GAPS was really simple to integrate and install, this has got the same ease of use. Yeah. Coming back to applications, you touched a little bit on shallow water performance, tracking underwater vehicles. What about towfish tracking, Paul? We need to put a little highlight on that, I think. Yes, towfish tracking is a very good application for GAPS M5. Mm-hmm. In fact, I think
gaps M5 is like a unique product for this application because of the horizontal tracking setup of towfish tracking. And very often, towfish tracking require less than 1 kilometer. And if you are able to use the pressure sensor embedded in the towfish, you can even improve the gaps M5 accuracy. And then if the towfish embeds an INS like Fins Compact C3, for example, or even higher, like for SAS sonar application, you will get a very efficient integrated solution with iXblue product. So it is really easy to install, really easy to plug with other iXblue products. Okay,
and then the unique acoustic architecture gives this extraordinary performance in horizontal tracking. That's the point. We touched a little bit earlier in the multitasking slide about AUVs, ROVs, and we've got a little comment about that as well, Paul, haven't we?
Yes, gaps M5 is also very interesting for AUV tracking. In fact, to perform horizontal tracking and with USBL in general, users as to tilt the antenna. With gaps M5, the user will not have to tilt the antenna at all. And whatever the location of the AUV around the vessel, or even for multiple AUV application, the gaps M5 will track the target continuously. And the recorded USBL position can be used to post-process the AUV navigation, and it is used to optimize the accuracy and reduce the drift of the embedded INS in the AUV. And now, if there is an iXblue MTB beacon and a fins in the AUV, this coupling between subsea INS and gaps M5 can be performed in real time. This integrated solution is really plug and play, and it gives already good satisfaction for our user of gaps.
Okay, so it's the kind of ease of use and portability of gaps, the omnidirectional capability, and then we can log the data for incorporation in post-process navigation solution, or indeed real-time update of the INS with using the telemetry. So the key sort of conclusions then, the takeaways here are gaps M5, a lot like the original gaps in terms of architecture. The key performances are, it's a 1,000-meter range, 0.5% of distance traveled, and the environmental performance in challenging acoustic environments or shallow water with horizontal tracking is really unique in the gaps range. Export free and free of any calibration through the life of the product in any installation. So what we've got now is some time for questions and answers, Paul. So I hope you're ready. We've got some questions which have come in over the course of the presentation so far. So there's a quick one here, which is, does the gaps M5 support data telemetry?
Yes, it is. The gaps M5 offer telemetry, binary data transfer capability. So it can be used for INS realignment, for INS coupling, for example, but it can be also used for any type of use like AUV control, AUV status recovering, whatever the customer needs, the telemetry can do it.
Okay, and I understand that's simultaneously with positioning.
Yes, absolutely. Yes. The point is the telemetry is a low data rate transfer, but it is really robust, and it can be used during the positioning. That is very important for this kind of communication.
Okay. So we've got lots of questions here coming in. How many targets can I track simultaneously?
The gaps can track up to 40 targets and up to 10 for a common interrogation code.
Okay, so we can go 10, 10, 10, and get up to 40 in a set, but 10 once a second or so, is it?
Yes, yes. The maximum rate is 10 tracking, 10 targets every 0.8 seconds.
Okay, great, thanks. So here's another one about beacons and tracking. Can I add beacons while the tracking is turned on?
No, this is not possible. You have to switch off the tracking, add another transponder, and restart the tracking.
And then restart. Okay.
Yes.
So there's one about accuracy in shallow waters, i.e., 10 to 20 meters of water depth. What will the accuracy in shallow waters be? I guess as a percentage of range is the way to answer that.
Yes, obviously, this is a percentage of the range. So in 20 meters, we will get something like 15 centimeters of accuracy.
Mm-hmm.
So in this condition, the GAPS M5 will be almost as accurate than the GAPS M7. So it's for this kind of application, very short range, the GAPS M5 is the product to use.
And that accuracy is available both beneath the gaps, but also in a horizontal mode. Is that correct?
Yes, it is the accuracy given for vertical tracking, but in horizontal tracking, the accuracy is almost as good as in vertical.
Okay.
So the 0.5 is you will get almost that in horizontal tracking, which is very good, really very good.
So there's a question here now about somebody's obviously been using the original GAPS. So same architecture as GAPS M7, but can it also track third-party beacons?
Yes, the compatibility with third-party beacons is exactly the same as the GAPS M7, the original GAPS. So you can track AXBlue, applied acoustic, and also every beacon that can be interrogated by wideband 1 modulation.
So there's a question here now about, obviously somebody's thinking ahead here about, the overlap between the applications and the performance levels of the GAPS, the original GAPS and the GAPS M5, GAPS M5, M7. And won't the GAPS how much of the work that GAPS M7 does today can now be done by GAPS M5?
I would say the GAPS M5 can do would be the best choice for really short range,
mm-hmm.
and the GAPS M7 remains the best product for longer range, like 1,000 up than 1,000, and for offshore application, for example. Mm-hmm. But for sure, for very short range, there is a kind of overlap between M5 and M7. But
sure.
It is. I guess it is only for very short range.
Sure, yeah. So what is this about the communication function? What's the maximum data rate obtained with the telemetry?
The maximum data rate is 20 bytes every recurrence of positioning. Every time you position a beacon, you can send 20 bytes of data. So it seems it is not a lot, but it is a very robust data link.
Okay.
It is not a modem.
Sure. Yeah, it's not designed to be a modem, but it's extremely robust and continuous with the positioning. So here's one about beacons. Which beacon can be used with GAPS M5? Are there any new third-party integrations?
No, at the moment there is no new third-party compatibility.
Yeah,
not for the moment.
So the compatibility is with obviously our own medium frequency beacons.
Yes, also applied acoustic, Theory 1000, and also with wideband 1 modulation. Okay,
so any wideband 1 enabled transponders, our own medium frequency transponders and applied acoustics, particularly because they have the GAPS codes embedded. Okay, there's a question here which we've already answered. Can we use the position and communication simultaneously? The answer is very much yes. So then the next question is, when will the M5 be available on the market?
The GAPS M5 is already available to be ordered, and the first unit will be delivered this summer by the beginning of July.
Okay, so we can ship by July, and they'll hopefully then be available. There's another question here within the rental companies. So perhaps a rental company will be a customer. Let's see. So there's another question here. Then is the GAPS M5 better than GAPS M7 for towfish tracking? I guess
no.
Range.
In fact, the GAPS M5, the idea was to bring the benefit of the original GAPS to new users. So the GAPS M5 is a cost-effective USBL solution for vertical and horizontal tracking. So GAPS M7 remains a bit better in every conditions.
Mm-hmm. Yeah, sure, I understand. We've covered the question here about another question about beacon compatibility. There's a question here, a general question about military applications. I'm not sure what that's driving at, but perhaps it's looking at AEV applications that we've considered. Here's one about elevation of beacons. Can we get the elevation of beacon with regards to the to GPS? So can we get a height of a beacon in the GPS reference frame?
Yes, absolutely. It is possible to use the GPS altitude informations in order to have the geo-referencing of the transponders in latitude, longitude, and altitude regarding the altitude given by the GPS. So the answer is yes.
Okay. So I've got a question here then about compatibility with existing GAPS cabling and topside units.
Yes, to offer a really easy of use to our users, we decided to keep the same connector on the GAPS top flange, and to keep the same cable, the same surface interface unit. So it is fully compatible from M5 and M7. Okay,
so interchangeable, completely compatible with cabling and topside units from the other model in the range, essentially. So here's one for you. Like this one, Paul. Do you plan to develop a GAPS with a flush array?
That's a very interesting question. In fact, we tested a different solution, and finally we decided to keep our very typical and unique shape of 3D antenna, because for horizontal and shallow water application, this is the best solution we found, and it remains, I think, better than a flush antenna.
Okay, yeah. So the trade-off, maybe it's a strange-looking beast, but it's extremely effective at the job it's got to do, which is tracking in shallow water and horizontal tracking.
Absolutely.
So there's another question here about telemetry rate, which we've kind of covered, I think. What is the telemetry rate?
The telemetry rate, it is in theory it is 500 bytes per second.
Okay.
But as the telemetry is used during the positioning, you are interlace positioning telemetry. So the effective data rate is 20 bytes every second or every few seconds. When you are sending in interrogation, you send the telemetry datagram.
Okay, yeah. Okay, there's more. Can the range be extended beyond 995 meters?
No, it is not. It is not because this is an export-free product. So the rules are strict, and we cannot deliver a system that is able to track above 1 kilometers.
So in order to remain free of export controls, the range is limited to 1,000 meters, very simply. So what is the maximum temperature the electronics can can tolerate? Deep in the specifications here.
Yes, the maximum temperature is 35 degrees.
Plus 35.
Yes.
Okay. Any more? Okay. Maximum cable lengths for the gaps.
The maximum cable length, so the standard package is a 20 meters cable, but you can order these gaps with a 50 meters or a 95. And you can also use two 95 cables with a repeater box between the two cables. Okay. Then you have a maximum length of 190 meters between the box and the antenna. Okay, so you can join the cables together essentially and get a 190, nearly 200 meter cable length. Okay, brilliant. We've got one here about calibration. Somebody delving into the calibration, the needs for calibration, and so on. So, is it really the case that no calibration is needed? And should the customer provide do a spin check in operation? So how can we arrive at a system which requires no calibration? In fact, we worked on the mechanical tolerances between the IHRS and the acoustic antenna. So we are controlling during the manufacturing of these gaps. We are respecting the tolerances. So by doing this, we ensure that we are better than 0.5% of the distance. But obviously, the user can do a spin test to verify this accuracy. There is nothing about it. But this product does not require any calibration. Whatever the situation, it does not require any calibration to be in the specification of under 0.5% of the distance.
Okay, so in order to meet the 0.5% specification, there's no requirement for any sort of calibration of the unit itself, but it would probably be good practice to perform some checks of the overall integration of sensors on board a survey vessel, but it's not necessary for the operation of gaps. Okay, clear. There's more. Is the wideband one function a standard, or is it an upgrade from the standard?
This is an option for these gaps.
Okay, so it's an as with the other one, the ability to track third-party beacons is an option that we can offer. So a general sort of question here: how delicate is the array when using a gaps from small vessels?
How is it? What?
How delicate is the transceivers and?
Obviously, this is a very important part of the product. So the user don't have to hold the product by the hydrophones.
Yeah.
Obviously, the user has to pay attention of the hydrophone on the acoustic, and if something wrong happen on the vessel, the user have to know that it is possible to change the hydrophone and the arm if for any reason the leg is broken. It is possible to change it the user by himself, and any calibration is needed after to get the optimal performances.
Okay, so if damage occurs in an operation, it can be repaired in the field. Having done that repair, there's no calibration required in order to come back to the system's performances. Okay, we've got more. Can I connect my GAPS M5 to a multi-beam echo sounder? Does it include heave?
The octants nano inside the gaps can be used for other purposes than USBL positioning. You can have every protocol delivered by the octants nano, so you can couple it with a multi-beam sounder. And you can also use the Eve, but it is not a survey grade INS inside, so the Eve is only a few centimeters accuracy.
Okay, so it's entirely possible to do the integration, but maybe there's a small warning on the quality of the heave from this particular model of AHARS, which is not at the highest level. So there's another question about testing. Can GAPS M5 be tested in air?
Yes, you can test it in air. But you cannot do positioning in air. You can make a test of the hydrophone in air, but you cannot position a transponder in the room, obviously.
Okay. So you can perform some functional tests, but not you can't test the communication, for example.
Yes.
So here's one about integration again. Can the IP range be changed to a user's own network IP configuration?
We have the same restriction as GAPS M7 for the moment, but the users have to know that we have to change something in the IP management, and we are actually working on this.
Okay. So it's clearly a known topic. So we got one here about DP, Paul. Can the GAPS M5 be used as an input to a DP system?
Can be used as a
position reference for dynamic positioning system.
Yes, it is, and it is designed for the GAPS M5 can be used for relative positioning of transponder when you deploy transponder on the beacons. So it will provide to the DP controller the relative position of the transponder you deploy. And it will also provide the position of the vessel itself using USBL algorithm if you want only one beacon. And it will use also LBL algorithm if you have deployed more than 3 beacons.
Okay, so entirely suitable for DP applications, several different modes of operation to give some flexibility in different applications. So we've got one here, which is it's another good one. You'll like this one, Paul. When will wideband 2 be available in GAPS?
I don't have the answer for the moment. We know this could be an interesting point for our product, but this is not in short-term development.
Okay, there's no answer for that question for the time being. So there's one here. Can one load new calibration parameters? Not sure quite what that's driving at. Does that?
No, it is not, because in fact, it is a trade-off. We decided to keep to prioritize the ease of use of the GAPS. So with this one, there is absolutely no calibration needed. So the user will not be able to change anything regarding the calibration offsets.
Okay. So just in terms of ease of use, the calibration setup is fixed. So we've got one here about shallow water performance. If position is unstable in shallow water, comparing with the GAPS M5, M7, what will be the difference in performance between the GAPS M5 and the GAPS M7? So
I see. With the GAPS M5, you have a bit shorter legs. So the difference in shallow water will be the estimation of the depth of the transponder will be a bit more accurate with GAPS M7. This is the main difference between the two products in a very short range shallow water tracking.
Okay, so there'll be a slight improvement with the GAPS M7 in terms of the vertical kind of resolution.
Yes, because this one is
coming from the geometry of the array. Okay.
Yes.
So here we go. There's another one about calibration here. If GAPS M5 is pre-calibrated in the factory and no calibration is needed, what do I do if we notice positioning error during operation? Tricky one, that.
Yeah. If you have a GAPS M5 and if you measure the accuracy is not as good as expected, you have just to contact iXblue, and we'll do what we need to do. We will correct this issue, of course.
Yeah. So a quick email to support@xblue.com to explore what the integration complexities might be or what the environmental issues could be. So what about the operating frequency and coverage? Also heading, roll, pitch accuracy. Yeah, so what's the operating frequency? And what's the accuracy of the heading, roll, and pitch?
For the operating frequency, we are using a medium frequency from 20 to 30 kilohertz. And concerning the heading, roll, pitch accuracy from the octants nano inside, we are 0.5 degree second latitude and 0.1 degree for roll and pitch.
Okay. We've got more questions. There's one here. There's another one about compatibility specifically with Kongsberg code. So any plan for symbol integration and C node compatibility?
Some of people at XBlue are in contact with Kongsberg people, and we are going to work as a partner in other topic, but we would like for sure to be compatible with Kongsberg, but it is I would say in a medium term development plan.
It's something we're looking at, but not yeah, it's we're not there yet. So now, how does a GAPS interface with your INS on an AUV?
To interface a GAPS M5 with an INS, subsea INS, or a fins compact in the AUV, you have to use a data link. So we propose at XBlue to use the MTB transponder, which is an OEM transponder with telemetry capability. Mm-hmm. So when you configure in the GAPS MMI the transponder of your AUV, you define the code and every typical configuration for USBL, and you also have to enable send the USBL position by telemetry. And then every 3 recurrences, the USBL position will be sent through the acoustic link mm-hmm. to the AUV, and the MTB transponder will automatically output the USBL position to the INS. The INS will be configured just before. Very simply, we just have to configure an input port, and then it is just plug and play. The INS will be realigned periodically by the USBL.
Okay, so in summary, you need a compatible transponder on the vehicle, and you need to set the gaps up to output position of the tracked beacon. And then inside the AUV, we obviously need to connect the data link from the transponder to the INS, and the INS will automatically start to use the time-stamped position data from gaps. Okay, there's more. What is the position update rate?
The position update rate is up to 0.8 seconds.
Okay. Is GAPS stable when the vessel moves?
Yes, this is a good question. In fact, this new GAPS is a cost-effective version of the original one. So we kept the electronic boards, we kept the acoustic processing unit. So we have a very high margin in terms of SNR. So even the vessel is making noise, even the environment is very difficult for acoustic, this GAPS M5 will be really stable in terms of USBL positioning. This is a strong benefit of this new product.
Okay, there's one here about acoustics. Can GAPS M5 filter sound?
Filter sound.
Do you understand that question? Is it?
I don't really understand the question.
Okay, well, we need to get a little bit more detail on that if somebody wants to delve into that. So we've got another question here about wideband 2. We've dealt with that one. Is there any is there any decrease in position around the horizontal beams? Any decrease in position accuracy around the horizontal beams? And can gaps be tilted in shallow waters to have better position performance, or is that not needed?
No, I would not advise to tilt these gaps. Obviously, the positioning accuracy is a bit better in vertical because of the distance, of the horizontal distance between the hydrophone. This is just physics. But these gaps, the difference between vertical accuracy and horizontal tracking accuracy is not really high. So I would not recommend to orientate to tilt the antenna.
Okay, yeah. So there's really no need. There's no advantage, or very little advantage, in tilting this antenna.
Yeah, it's possible, but the advantage is not really important with these gaps.
Okay, great. So now there's a lot here about sea states. Which sea states can GAPS M5 be used into? Which?
There is, in fact, there is no real limitation because in these gaps there is an embedded IHRS. So even these gaps is moving a lot. Yeah. The tracking will continue. The geo-referencing of the transponder will be stable. So even if you don't have any bubble around the acoustics, this system will work.
Sure. Okay. So notwithstanding the kind of aeration or the acoustic environment of where it's deployed, there's no limit on sea state. So we've just got one. We're coming back around to the maximum number of targets here. This is probably going to be our last question, Paul. But what is the maximum number of targets that can be simultaneously tracked?
It is. You can enable up to 40 targets in the configuration page. So you can you can track up to 40 targets, and you can track up to 10 targets with a single interrogation code. So within 1 second, you can position up to 10 targets. Okay.
I think we've just got one more question, which is just taking shape here. And it's about cable lengths. So if we use cables over 50 meters with the GAPS M5, do we need to use an external power supply?
No, it is you can use the 95 meters cable without any other box.
Okay.
Just a typical setup: the box, the cable, and the antenna.
Yeah. Okay. There's more questions. It's not over yet. We've got one about how fast an AUV can be tracked reliably. So is that
yes,
so how far?
I mean, good question.
Yeah.
It is using our MFSK modulation. You can track AUV or even maybe torpedo. It is still possible. I don't want to make a mistake giving a wrong number, but you can track vehicle slightly upper than 20 or 30 knots. Okay. So not entire. We don't have a precise number, and maybe don't want to get into too much detail on that, but fast. So there's another one coming back about testing in air. How long can we test the M5 in air? We do not recommend to let the gaps pinging in the air because it is not designed for. But you can test it in your warehouse, on your vessel, on the deck of your vessel. This is there is in fact no restriction concerning the time you can test it in the air. Okay. So we've got a question here which is about how can we use the GAPS M5 to communicate with an AUV in modem mode using a compatible beacon, but without using the towfish modem, the positioning modem? I think the question is there another channel? So there's a positioning beacon, and is it possible to use another modem on the vehicle simultaneously for communication? Yeah, yes, it is. It is. In fact, sometimes when people want to use USBL system modem on AUV, they could have some issues because they are using the same acoustic band between the modem and the acoustic signal to trick the transponder. But with GAPS, we have different kind of modulation using wideband modulation like MFSK, wideband 1, and these modulation are really strong to avoid some issues of interfacing, interferences, I mean, between two kind of systems.
Okay, that's clear. That's good. Here's one about sound velocity. How can the sound velocity profile data be loaded into GAPS M5?
The sound velocity profile can be loaded in the GAPS using the web MMI by selecting every cells manually, I mean, or you can load a SVP probe sensor file directly into the GAPS.
Okay, so there's some flexibility there. We've got one here about beacons, triggering beacons in responder mode. How many beacons can be triggered simultaneously with each surface unit sync output?
You can track up to 10 beacons simultaneously, whatever you are working in transponder mode or in responder mode.
Okay, so you can signal the response to up to 10 beacons.
Yes.
Okay.
Yeah, absolutely.
Yeah. Okay, here's another good one about integration. Is there any difference between the GAPS M7 and the new GAPS M5 mounting flange dimensions?
No, this is pretty the same, and this is a choice. We wanted to keep the same mechanical top flange, the same footprint, in order to allow our users to use M5 and 7 on the same deployment method. Okay,
yeah. We've got one here about QC, real time, so about error codes and so on. How do we know if the embedded gyro or AHARS has got a failure?
Well, in the GAPS web MMI, you will have a status panel, and so you will get the information about the status of the AHRS. So if you have any kind of failure, you will see an error on the web MMI. Okay.
Okay, so here we've got a question here which is about it's a what if question, and it's anticipating some problems. So what if the GAPS M5 gets dropped or sucked to 110 meters immersion? I don't know. Oh no, what if the GAPS M5 gets sucked to 1,100 meters? Any responding mechanism? I'm not sure I understand the question. I don't know if it's about if it measures a range beyond 1,000 meters.
Yes. So if you have a beacon at for example 1,200 meters, you will not be able to track this beacon. There will be no issue, but you will not get the position of the beacon.
Okay, so if the beacon goes beyond the 1,000 meter range, GAPS M5 stops tracking it.
Yes.
Clear. Okay, I think that's about it for questions then. Maybe we've got one more. We've got time for one more. We're just going to wait 1 second. I think there's possibly one more question coming. One more question. Yes or no? Yes, it's coming. It's coming. It's coming. Here we go. Here it is. It better be a good one. Okay. Okay. Yeah, it's a good one. It's a good one, Paul. So this is about calibration interval, and it's relating to the AHARS, the inbuilt AHARS. What's the recommended calibration interval for the Octans Nano in in the gaps, do we need to calibrate the AHARS, the gyro inside?
No. There is no calibration to perform at all with GAPS M5.
Okay, so there's no calibration required for the GAPS M5 or the AHARS inside it. And we've got more questions. Is GAPS able to choose the better frequency itself in a noisy environment?
No, it does not. However, it is a good topic. It is a good topic for an improvement, and the users has to know that we are periodically doing some firmware release. So we add some features on our product, and almost every year we provide a new firmware to users. So this kind of improvement could be done. Obviously, and provided for free to our users.
Sure. Okay. So it's not in the product currently, but it's something that perhaps might be added. So thank you for the question. It's very good. So I think that's all we've got time for in terms of questions. So I think we've had about best part of 150 viewers, Paul. So thank you very much for joining us here today, Paul. And
thank you, David, for presenting this webinar, and thank you everybody for attending it. Yeah. And you have to know that if you have other questions, feel free to contact XBlue. It will be a pleasure to answer your question and to define what is the best USBL, GAPS M5, GAPS M7, or even other solution for subsea positioning. So feel free to contact us for any question. And thank you very much.
Thank you very much, Paul. Well, good. That wraps it up for our GAPS M5 webinar today. Thank you for joining us. I hope you enjoyed it and you learned something and had some of your questions answered. As we said before, if there's any questions that weren't answered, please let us know, and we will certainly address them, whatever they are. So XLive will continue. We have another transmission of this GAPS webinar later today, and then later for your calendars on the 9th of April, we have another pair of presentations about our Delft subsea positioning products and the developments in that area. So we'll hope to see you at one of these future events. Thank you very much for joining us today. Goodbye.